Uh, Hello, everyone. I'll mute myself here, Tobias. Okay, so hello, everyone. Welcome to the first guest lecture, where today we are going to have Tobias. He's going to speak to us about business intelligence, and we are going to learn from the expert himself. He's on another room, waiting for me to turn him on. So just in a couple of seconds, you will see him speaking to us. I'll be here to help you guys like answer questions, or I'll basically moderate between him and you guys. And we are going to have about 45 minutes session with him, where as I said, he will speak about artificial intelligence, business intelligence, and how everything is tangled. Recently, like last year, he made an amazing book about the topic. So if you're interested in the book, please ask him about it. And yeah, so I'll in a couple of seconds I'll mute myself. I'm here, so you will see him being prominent in this call. So, but yeah, if you have any questions, just ask it in the chat, and I'll jump on and yeah. So yeah. Oh yeah, yeah. We can jump and ask and start speaking with him. So let me bring him to the Twitch, and we don't have to start immediately with the presentation. So hi, Tobias. Uh, first
Hi,
of
Luca.
yeah, first of all, thank you so much for like having time to join us today. I know that you have really busy schedule, and we have amazing people in the chat. They are all like tech savvy people who are trying to learn machine learning and jumping on this road that you and I have been going for so long at this moment. So yeah, you can start by introducing yourself if you want to like speak about your background and stuff like that before we join in the session.
Yeah, great. So thanks, Luca, for the kind introduction. And it's great to be here. Thank you very much for having me. So I'm really excited for this session. So hello, everyone, wherever you're calling or listening from today. So I'm really excited for this session on AI for business intelligence, which is, as Luca mentioned, one of my key topics because last year I just published a book about that. And let me quickly share my screen so I can give you a quick introduction to the overall topic. No worries, this will not just be a presentation today, so I'll also do some demo later on and some hands-on stuff. But honestly, I think before we start with the really technical topics, I think it's good to go through some of the basics so we are all on the same page and we all know what we're talking about when we talk about AI and especially BI. And so, yeah, before I start off, I'd like to quickly introduce myself. So, yeah, I'm Tobias. I'm based in Germany. I'm the co-founder and managing partner of Rapid AI, which is a company here in Germany helping businesses to implement AI and machine learning solutions. I've also been a data science mentor for a company called Springbird for a while. And overall, I have more than 15 years of professional experience. And as I just mentioned, last year was the time of my first book, which came to life. This is called AI-powered business intelligence. I'm really excited for that. And also, please feel free to reach out anytime. Either drop a question here in the chat. If you have any question, please put that into the chat, or also feel free to reach out on LinkedIn. Feel free to message me to connect. So I'm really looking forward to meeting you here. And yeah, also looking forward to this session today. And this will be the small agenda that I have brought for you today, because I think probably you come from different backgrounds. Some of you are more technical. Some of you might be not that technical, especially with regards to Python and AI and machine learning. So the first part of this presentation will really be to give you a light introduction to AI and business intelligence. We will then talk about the different impact areas that AI can have on BI. And then I will run you through 3 examples of how you can use artificial intelligence in the context of BI. And by the end, if you hang out for 1 hour, there will also be a small surprise for you. So that will be by the end of that session. And yeah, I'm really looking forward to that. Luca, what do you think? Shall we start, or shall we wait for a couple more seconds until, or maybe there's any question already, and we should answer that?
So far, no questions. I'm just curious, is everything from technical standpoint okay? Like, do you hear him well? Because like this is the first time that we are doing kind of a share screen situation. So please drop a comment in the chat if you are okay with that. Okay, nice. So we are great on the technical side. Yeah, you can continue. I'll mute myself and great. So
Okay, perfect. All right, so then let's go. So first of all, introduction on AI and business intelligence. And honestly, I think let's start with BI because you probably heard something about AI already. We'll talk about that in a second, but let's talk about BI because I sometimes feel that this term is, kind of forgotten sometimes. So business intelligence, what does it mean? I see it very much from a system or software perspective, a software that enables business users and analysts to look at data from multiple sources within an organization with the goal of making better informed decisions. So if you break it down or if you compress it to one sentence, it would be turning data into better decisions. And when people talk about BI, especially in the corporate world, they often associate a lot of those underlying systems and infrastructures that go with that whole setup. Because especially in larger enterprises, it's like a very large infrastructure that you're running in order to bring those insights or like these reports to your users. And what people typically associate if you talk about BI, then it's the big BI platforms, the big BI vendors. That is Microsoft Power BI, which is probably one of the biggest out there, and Tableau. A lot of people have probably heard about that, but also other platforms like Looker or Click and so on, and the whole underlying infrastructure that run these systems. So if I talk about BI, that's what I mean when I talk about BI. And with that said, now what is AI? So first of all, and I don't want to be like, I don't want to hang out on that topic here too much, but the term AI has actually been around for quite a while, actually since the early 1950s. And it all happened with military research. So that's when the coin was originally coined, or when that term was originally coined. And since then, since the 1950s, there have been like two broad streams or two broad categories of AI and AI research. And the first category really is called general AI. And this one helps to aim to solve any given problem that the system has never ever seen before. So this concept of general AI is still a research topic, but honestly, it has not really been put into practice. Even though we see a little, even though we see a lot of progress happening, especially with systems like ChatGPT and so on, but still we haven't reached general AI yet, and no one knows if we will ever reach that point. So let's focus on a second area, which a lot of people have been working on recently, and this is in an area called narrow AI. And narrow AI aims to solve a specific problem that the system has been designed for and trained on. So that means these are systems which can't solve any problem, but systems which can solve a very particular, very specific problem pretty well. And this is what we call narrow AI. And now to bring on a third terminology or a third term here, and that is machine learning. And how does that fit into the picture? Well, machine learning is essentially the technology that has powered all the recent breakthroughs we have seen in narrow AI. So whether we look at ChatGPT or at other large language models or at other AI applications, it has essentially been machine learning that made those techniques possible. And so when I talk about AI, I refer to narrow AI, and that's why I also kind of like use both terms, AI and ML, interchangeably because they are so heavily connected together. So that's my definition of AI. And you heard probably from Luca already what machine learning is. I'll just want to recap on that to make sure we're all on the same page. So in a very simple, expression, machine learning is a programming paradigm that aims to find patterns in data for a specific purpose. So pattern finding in data, that would be in a nutshell what machine learning is all about. And it has two phases, the training and the inference phase, which is also called the testing or prediction phase. And the core idea really is to find patterns in historical data to solve a specific task. So that is an example of narrow AI, right? So we are looking into a specific problem. We want to solve that problem with historical data, and then we want to try everything that we learned from the past from that data and predict that and use that to predict the future or anticipate future events. And there are like vast applications or lots of applications around that, especially in business, like forecasting trends, scoring probabilities, finding similarities between items. So there are plenty of use cases around here. So now, why should we care especially about AI for BI? So bringing both concepts together. Well, and one of the main reasons is that the volume of data overall is still growing rapidly. So if you look at this chart here, which is taken from Statista, and you will see that the whole worldwide volume of data and information created, captured, and copied is and consumed is growing and growing without any stop. And I think each of us or every one of us can actually relate to that if we just look at the data that our cell phone is consuming every month. So probably when we started out, I don't know, 10 years back when the iPhone was introduced, we were used to maybe consuming 10 megabytes, 100 megabytes, 500 megabytes of data, of cellular data per month. And now we have plans covering like 20 gigabytes or more per month. So that, gives you already an impression of like what the data size and data volume is that we consume and that we process. And this puts organizations into a very tough spot, because organizations are very often still able to handle the large data volume with modern technology, but they are only sometimes able to handle the growing complexity with the data management, because it's not like that data is growing in nice and ordered and tabular form, but data is growing in complexity. We have different data sources, we have different data structures, we have different data types, all growing like on their own without any underlying rule around that. So that makes it really difficult for organizations to deal with that complexity. And as I said, some organizations are able to handle that, but these are really just a few. Like a lot of organizations still struggle to make sense of their historical data and even do descriptive statistics from all their data sources. Oftentimes, it's very focused around certain data silos or the data sources, but not so much from all the data that they have in their company. And rarely, and this is really just the like top percentage of companies out there, organizations are rarely able to really draw insights from all data. And this is due to the shortage of data literate people. It's not only about technology here, but it's especially about bringing people in that can actually interpret this data and make sense of it. So this is the complex phenomenon that we see. We have more data and we don't have enough people really to make sense of it. And it's quite challenging technically to handle these the complexity of these data sources. And if this wasn't enough, there are even more three trends that fuel the need for AI in BI. And this is as a first point, the need to get quick answers from data. So organizations today need data-driven insights in order to stay competitive. And analysts are often overwhelmed with inquiries, and business users expect quick and easy answers, as they are used, for example, from like big search engines. So it's very hard to explain business people why they can go to Google and search for any news they want, or forget any latest stock prices or any data they want. It's so easy over there, but when they look into their own organizations, it seems so complex and so difficult to get this information from their own internal organizations. So that really fuels the need to get quick answers from data. They just have the expectation that it goes fast. And the second is, we call that the democratization of insights. At least that's what people want. Business users, they have been accustomed to self-service BI solutions, like these have been around for years. However, today's large and complex data makes it really hard and difficult to serve that to users. I give you an example. Let's think back to the early days of OLAP cubes, of first BI platforms where we had maybe, I don't know, the data with 10 dimensions or 15 dimensions, different measures, different fields that you could slice and dice all together. Nowadays, we're looking at data sources that give us like dozens or even hundreds of different fields or different data dimensions to experiment with. And this is something that, a lot of business users can't really handle. They want to get the insights on their own, but at the other hand side, the data is so complex that it's very hard for them, like on top of their normal work to get the insights they want. So that's the second trend. And thirdly, the last one here that I see is that people see the technology, especially in the ML space, is becoming more accessible. So we're talking here about low code or no code platforms that make it easier than ever to use ML capabilities. So non-data scientists can use it actually, and especially if you have data knowledge, these tools allow you to like explore your data on your own. And this, of course, puts pressure on the BI team, on the BI teams that are often not really making use of those low code or no code platforms in order to provide a better experience for their BI users. So these are the three trends that are really fueling the need for AI in BI, and regarding the overall ecosystem and infrastructure, the overall ecosystem and world we live in, where data really grows exponentially, these become really critical. And also, and I think, at least from my experience, a lot of people find that surprising. If you take a look at business intelligence, and that would be like my third argument here why we should actually care about BI, is that BI is not going anywhere. So BI has been around for almost, I think, 2 decades or so. It has been around for a very long time in organizations that have been trying to make sense of their data and their data warehouses. And as you can see, for example, from this Google Trend chart, is that if you compare BI to machine learning and data science, it's actually still growing, and it even has more search volume here in the United States, for example, than machine learning and data science. But without being like too picky about the numbers, I think the main point or the main goal is here to stretch that there have been a lot of terms come and go. For example, big data, there was in a hype for quite a while, but BI has always been there, and we see that steady growth. So especially in large enterprises and in big corporations, BI is still a hot topic, if you want so. And that's why it really makes sense to also focus on that area and think, okay, how can we actually apply AI in that space? And this leads me to the impact areas of AI and BI. And this will be a conceptual overview for you, so you learn how to navigate the field and how to find use cases where you can apply AI to make the BI world easier. And after those impact areas, I will give you an example of, I will give you 3 examples, and we'll take a look at one case study so you can see how that actually, turned out in practice. So let's take a look at the impact areas of AI and BI. And to start with a very common misconception here, and very like a thing that I think a lot of people get wrong at the beginning, is they think AI is somehow like the next stage of BI. They think, okay, first I need to figure out my BI. Everything has to be perfect. All the reports need to be there, and only then I can think about AI and doing something. But actually, I think this is not true. This is it's completely the opposite, because I think that AI is an enabler that can improve BI systems, reportings, and dashboards across all the different analytical levels, starting from descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics, and even data ingestion, so even covering the data we analyze. And let's take a look how that turns out in practice. So the first impact area that I see for AI and BI, and I call that automation and ease of use. And this one especially covers the phases of descriptive analytics and diagnostic analytics. For example, we can use AI to help make the BI tool more intelligent and easier to use, and more accessible for non-technical users. For example, AI can help you to comb through data in seconds and suggest insights, discover interesting correlations or unusual observations. Um, Take the example of having a large pivot table with, I don't know, 40, 50 different dimensions in there. And normally your task would be to go through all of them like manually and just discover what could be interesting patterns here for a certain problem that I'm interested in. But thanks to AI, this task can actually be really accelerated, because AI can suggest to you which of these insights or which of these correlations could be really relevant for your problem. And what we see typically is that these capabilities are built inside into the BI tool, and I'll show you an example in a few minutes how that works within Power BI. But these are things which are typically built inside the application layer of the BI tool. The second impact area is what I call better forecasting and predictions. And this is honestly this impact area where most people think about first when they think about AI. Because obviously, AI can help you to produce better forecasts with more data and less human supervision. So that would be the prediction on a macro level. Imagine you have a trend chart where you have a trend graph where you have a line chart, for example, predicting the amount of sales for the next quarter. And maybe up to now, there was a regression model in place which took the historical data for the sales aggregated by a quarter and then just forecasts that over the next quarter. Of course, we could now use AI in order to have a more granular or to have a better model that's actually predicting the future better and also incorporates maybe more data from the past, or it's also more sensitive to different signals in your data, such as different trends or seasonality aspects. All these things can help you to produce better forecasts on a macro level, essentially by building more complex models. But at the second bullet point, we can also use AI to calculate predictions at scale for optimized decision making, and I call that predictions on a micro level. What does it mean? So, for example, let's say you want to predict the number of customers that will be in your business next quarter. What you could do is you could just take the aggregated information about how many customers did you have last month or the month before that, and just try to use that in order to make a prediction. Maybe use a complex model in order to make that better. But now AI helps you to go on a micro level and actually make a prediction for every single customer in the company and predict if that customer will be still in the business next quarter or next month. And then only after that, you can aggregate this information and come up with a estimate of how many customers will be there, or to put it in a different form, how many revenue will be lost over the next 4 months by customers, for example, churning for your business. So that would be a good example of how AI can be used in order to make predictions on a micro level. And the interesting thing about that is that these are techniques which can be integrated in the application layer of your BI system. So it means maybe it's just a built-in functionality which you can use, but you can also add that separately to actually any BI system out there on the data level, like on the analytical layer. So let's say you have a data warehouse where your data is stored, and you can use a service in order to make predictions on that data and score this data in the data warehouse, and then the BI system is just consuming the data, so it's just showing that to the users. So that means you can actually use that technique no matter what kind of BI service or BI tool you are using in the front end, which obviously makes it very, very powerful and very good skill or very good technique to have in your tool set. And then thirdly, and that is the last impact area I see, is data ingestion. And for me, this is the ultimate proof that AI is actually covering the whole life cycle of analytics, because AI can really help you to increase the breadth and depth of available and machine-readable data by turning unstructured data sources, for example, text or documents, PDFs, images, and so on, into structured data. That means into tables. And this is everything that BI platforms are all about. Like, they are all about tables. So, they want to have data in tabular form. And this is where AI can help you. For example, let's say, and we'll take a look at this example in example 3 today, we can use a computer vision AI service, for example, to extract information from PDF documents in a structured form and then return that to the BI service so we can analyze that data. Or we can, for example, use text data and turn that into structured information by getting sentiment scores of user reviews, for example, or keywords that are associated with like positive or negative reviews, and so on. So there are plenty of examples. And if you really think about that, most of the data growth that we saw at the beginning is fueled by unstructured data, then this can be such a powerful leverage here in order to make sense of that data and to interpret this data. And technologies used here include computer vision and especially natural language processing. And I don't have to tell you what breakthroughs we have seen in the context of natural language processing. So this is really, really an exciting area where we can put text information into structured information by For example, using large language models, as we have seen with ChatGPT, for example. So, and as I said, these are all the stages, like this affects all the stages in the whole analytical life cycle. So once we have new data ingested in our BI service, we can do descriptive analytics, diagnostic analytics, predictive, and maybe even prescriptive analytics based on that data. So it's a really, really powerful technique if you are able to use AI in order to unlock more data sources. And that's why I think, and I hope I could convince you to see it in the same way, why AI is an enabler for BI across the whole analytical data life cycle. And it would be too short-sighted if we say that AI is only the next stage of BI and just think about prescriptive analytics or so. I think that's not the case. AI is really an enabler for BI across all of those stages that we see here. And that's the point where I would like to go or walk you through some of the examples which I have brought for you today. And maybe before I dive in, I'll take a quick break and just ask if there are any questions so far on the theoretical part before we jump into the practical part of that session. And you will see some of the real applications of AI in BI in the world out there. So if there's any question, please feel free to ask now, and otherwise I'll continue in a few seconds.
Nice. So yeah, it was amazing part. Like I learned learned from this part as well. So far on Twitch, we got just one question about slides. Are they going to be like shareable to the participants?
Yeah, sure.
Nice.
I'll distribute them afterwards, so no problem about that.
Great. So in that case, like guys, I will add the link to slides in our Notion page, so you can all download it whenever you need. Before we continue, do you have any more questions for about this part, or we are good to go? Okay. So my question is like before we continue, if they are thinking about oh, there is one question. Are you referring to a narrow AI as enabler for BI?
Yeah, I'm referring to narrow AI because just of practical reasons, there is no general AI yet. So that's why I'm referring to narrow AI. As I mentioned before, general AI is still a research case and we haven't really seen practical applications of that. So whenever I mention AI today, I mean narrow AI. So yeah, just to be clear about that.
Great question.
Yeah,
and how about like practicality of business leaders? Like when you approach them with this, how often do you feel that they are understanding like what BI is versus machine learning, and how often do they make like uneducated decisions whether or not should they go with BI because they are coming from the place of not understanding what actually it is, and so you need to explain to them like what you did to us today.
Yeah, I'm repeating myself all the time because there's such a big confusion around all these terms around there. And not only because people like don't know, but just because like everyone thinks something different, thinks about something different when they hear AI or BI. And the worst thing you can do is that you say, "Hey, I have a like shitty BI service. Now I'm taking AI in order to solve all that." Right? That's not how it works. But the way it works is that you can use AI in order to maybe help you, clean up those things or get to the insights faster. But if you have fundamental problems in your whole setup, if you don't have access to data, for example, then AI won't help you. But AI can help you if you have, for example, like access to like too much data, and it can help you to like comb through that. But that still does not kind of like take the responsibility away from you to like have good data management in place where you look for high quality data in order to make sure that these insights that you're getting there are actually reliable. And so talking about like how these things play together, that's obviously always a big part right now. And especially, with that big hype around AI at the moment, it's always important to kind of just like, to structure that and say, hey, what are the actual application areas where you right now can benefit from, and what are other just research cases kind of.
Yeah, and like one thing that I would definitely mention there, like having a lot of data does not mean that it's good data for AI.
Yeah.
Like, well, if we are just censoring, like if it's a censoring data, it might be really noisy and we can't do anything with it. So having petabytes of data does not mean that actually we can utilize it.
Yeah.
Did you come up with that case like somewhere where people had a lot of data, but it was actually poor quality data?
Yeah, the good thing is if you approach that topic from the standpoint of AI, then my experience is that a lot of companies actually have, some kind of governance or some kind of structures around that, because typically they have already a reporting system in place. So you can expect that they have kind of already asked themselves, hey, what data do we need in order to report that to business users? And typically when you have that, there's some kind of alignment or government around that data sources which live in the data warehouse that is reported for analytical purposes. But still, especially when it comes to like unlocking new data sources, or like, as you say, sensor data and these things, and people want to integrate that into their BI like quickly with AI, this is some area we have to say, like, we need to go through actually the same cleaning and quality steps as we do with any other data that we put into our data warehouse. So yeah, this is definitely a big issue.
Nice, thanks. We have two great questions in the comments. Like, first was how different is perspective analytics step than predictive analytics in BI?
Predictive versus prescriptive, right? That was the question.
Yeah.
Yeah. So essentially, like the way I define it is that prescriptive is actually predictive plus suggesting an action. Let's say you have the example of customer churn. An example of predictive analytics could be to predict the churn score for every customer for the next month. So that would be a percentage number, for example, and that would be predictive analytics. So prescriptive analytics would now essentially like add another column to the problem and maybe put that into a categorical forecasting or categorical prediction problem, where you say, I have a certain amount of possible actions. I can take, I can, offer discounts, I can do personalized emailings, I can call the person, and what should I do now? And this is prescriptive analytics. When you apply these kind of suggestions to predictions that you're making and saying, like, these are the things I should do based on the things I learned from the past. This is the step where we talk about prescriptive analytics, especially when it comes to the realms of machine learning. There are also other types of prescriptive analytics which do not involve machine learning, but I think that will be kind of like too far-fetched from now. But bottom line is, you have a action that you want to suggest in the end. That's how I differentiate both in an easy way.
Yeah, same here. Great. And the last question for now, at least, is what level of confidence do we generally expect as a companies or slash users when the BI platforms predict some actions or suggest some actions to us?
Yeah, that really depends. It's hard to answer that, on a general level, because it depends on the risk associated with with the decision. For example, there might be decisions in the business where, like, even making a wrong educated guess isn't really bad. Take the example of lead scoring, for example. Lead scoring is a machine learning use case where you say, I have a list of leads, and my salespeople, they need to call those people. They need to call those leads or need to qualify them. And now you can use machine learning in order to rank those leads and essentially say, hey, I want to have the like highest potentially highest converting leads, like, at the top of my table, so salespeople can just call them directly. And in that case, even if the prediction for the individual lead is like not really correct, or maybe it's not high enough, or it was too high, it's actually not so bad at the end, because the baseline before was still, like, so bad. It was practically non-existent. Maybe there were some very low barriers, but the advantage that machine learning can bring in this case is huge, and the associated risk isn't really there, because, I mean, what happens, right? You maybe call the wrong person, but you would have called that person anyway. In other applications, for example, in medical applications, or anything I would consider as high risk applications, there is the risk there is much higher. So you need a much higher confidence in order to really trigger an action based on what AI predicts. And this is is essentially the questions the question of trying to balance that out. The improvement that AI or ML can give you over an existing baseline compared to the risk associated with making a wrong decision in that case. Because we have to be sure ML is always making wrong predictions. In the end, right, there's no ML system which always makes the right predictions. The question is just how often wrong are you? But there will be wrong cases. And this is why those high risk applications in AI and machine learning, such as autonomous driving, are so hard, because every wrong prediction here can lead to fatalities. And this is obviously much harder to control compared to like showing ads to users, right? Where in the worst case, the user gets an ad shown which he didn't like. So
those are great points, and actually you are summarizing something really important, which actually is the last question for now. So guys, we're going to answer this question now, and then we're jumping to example, and obviously we're going to second batch of questions later at the end of the session. But yeah, you brought some great points, like about high risk versus high reward, or stuff of the application. Like for example, if we had the application in healthcare industry that you mentioned, like relying on AI, I would definitely not suggest relying solely on AI to make the final decision. But like, even though we make for example, a wrong decision whether or not some patient has a cancer or whatever, like ultimately we are going to suggest that patient to be checked by the doctor. So in the worst case scenario, that there will be a double check. But the last question on that point is, how often, or when we talk about AI powered by AI, do we expect to some level to have a human in the loop, kind of a cycle or feedback loop, where when for example, this wrong prediction comes, whether or not, for example, you are suggesting a patient that has a cancer but it does not, so it's a false positive one, and we are just double checking it, like what's your experience with that? Like, do we have to have something like as a safety net with a human in the loop, or do we have to just rely on a system as an expert in this case?
Yeah, it's a great question. So in 99% of the examples that I give here, I consider a human in the loop. We can also call that augmented analytics, or like human in the loop analytics, or whatever. But the idea is that we have humans sitting there making decisions, and then giving AI to them as a tool in order to A, maybe make better decisions, or B, make decisions faster. Because even if you come up with the same decisions in the end, if you have a tool that allows you to like come to that decision much faster, this is also a big business value. So it's not always about like improving the quality of the decision, but sometimes only the time to insights, or the time to action, or time to decision, however you want to call that. And I think the really rare examples of where there's no human in the loop whatsoever is, for example, when we look at reinforcement learning. For example, if you want to do prescriptive analytics on large amounts of data, where we automatically suggest customers, or people that are likely to churn, automated offers, and we get feedback on that, and then based on that feedback we train our learning algorithm, and essentially have a reinforcement learning system in place. This is something where this is obviously not human in the loop learning, but automated learning. But for these cases, you need a lot of data, and also those kind of low risk applications. But the majority of use cases that I deal with and that I have seen were all about empowering people and helping people to use AI in order to make better decisions, or make decisions faster.
Nice. Cool. So thank you for great answers, and let's continue with your presentation.
All right. Thanks for the great questions. So I'm happy to answer more of them by the end of the session. So feel free to use the chat for that. So by now, I want to give you the first example of how AI can be applied in BI and practice, actually. And the first example I want to give is how you can explore data with natural language. And actually, I've made these slides before ChatGPT came out. So these have been actually around for quite a while, but still, it's the same idea behind that. So what's happening here? I took the example of Power BI as a BI platform. And remember, we are now in the phase of making it easier for users to interact with data. So this is something that is typically happening in the application layer of an BI system. So, technology like that exists in Looker and Click and Tableau, but obviously also in Power BI. And in Power BI, this feature is called Q&A. And what happens here is that users have the option to interrogate or to ask their data any questions they have. And it turns out that people are actually pretty good at doing this because they have been trained, on this process for years. Ever since search engines like Google have been around, people are used to type queries into a prompt and just get like answers or get data back from that. And you can also leverage the same mechanisms inside your BI system in order to help people ask questions in natural language. For example, like what were my sales last week, or what were my sales last week in the US compared to Europe? And the reason that you can ask these kind of questions without relying on static keyword matching to tables in the background is made possible through the advancements we saw in natural language processing technology, which really makes the whole user experience really easy and convenient. And just to give you an example how that looks in Power BI, for example, is that the user essentially has 4 components here. They have a text box where they can type their questions or queries. They get automated, autocomplete features where they just start typing and they get suggestions for what they could ask. There are suggest questions, which is essentially a pre-populated list, which contains sample questions, which a user can run with a single click. And this, can be a question like, what were my top performing products? What are the highest sales regions? Anything you can imagine inside a BI tool. Right? These are things you can customize, and you can customize that, using different options here. In point 4, this settings icon. If you click on that in Power BI, there will be an option screen where you can define custom keywords for your business, where you can also see what users have been searching for, where you can see what kind of suggestions were made and what the answers were given, so you can try to improve that whole process and also suggest questions to the front end of your users. And then once you type a question, Power BI will essentially come up with a chart, with a line chart or a bar chart, for example, showing you this information, and then you can convert that into a static visual and just have that on your dashboard if you want. And just to give you an idea of what kind of questions you can ask, in that case is, for example, you can ask natural language questions like, which sales have the highest revenue, but you can also filter your data by saying, I want to see sales in the last year, or by variables, sales in the US, for example. You can combine conditions and say, I want to have sales for product category A or B. You can have specific visuals. You can say, I want to have sales by product as bar chart, and so on. You see this list here. And what I think the really stunning thing about that is, this is not any research preview, or this is not any research case. This is built into Power BI, which has millions of enterprise users, and it's out there. You can just use it. So it's an enterprise-ready feature of NLP integrated into a enterprise piece of software, which really allows a lot of people to use those AI services. And what I've seen is that many people aren't even aware of that capability, and some of them are maybe aware of it and said, they have used that maybe 3-4 years ago, and that didn't work so well, and didn't try it out and again. But by now, these things are really good. And if you look at how especially Microsoft is pushing their integration of OpenAI and an NLP service into their systems, then I can only imagine how good this will be in a couple of weeks, months, or years ahead, depending on how fast they move. Because right now, all these queries are interpreted by natural language processing technology, but not by large language models. And once you have large language models here in that loop, you will probably be able to ask even more complex queries, or ask queries in even more complex language than you can do currently. And again, like there are different features, that make it easier for you to navigate the different options, for example, and like that really help users to comb through their data and to interrogate their data and get the insights they want based on a simple search query. And typically also, especially in Power BI, this Q&A tool helps you to identify the best plot or access type. For example, if you have a variable by year, it will recognize that year is a date column, and then it will suggest a line chart and not a bar chart, for example. So this is one of the practical examples, and here's a short animation of how that looks like, because I can't show you Power BI right now, but this one is taken from the Power BI website, so you can see how that turns out. And you can see, how a user is actually inserting some keywords here that relate to a variable, but these are not the exact column names in your data schema. This is just translated to what the correct interpretation of that could be. And this might seem simple here, but having something like this, if we think back to democratization of insights, this is such a game changer, because imagine how many like drill down levels and fields and measures you would need as a pivot table or in your data model, so users can actually have access to that. By now, they can just ask the question, they can just ask for the information they want and get the result back. And this is much more natural compared to like, drawing different or putting different pivot table fields together, especially for the majority of business users. So that's the first use case I wanted to share with you. And again, I'm going to share the slides later on if you want to learn more about these. I put some links here so you can just dive deeper and see how these work out in practice. So example 2 I want to show you today is the so-called key influencer tool, or you can also call that automated pattern finding in data. And this one is also a Power BI feature, but again, these things are integrated also in other BI platforms, so you can use them. But they're also like Python libraries you can use in order to like build a similar functionality on your own. So it's not really about the tool, but just about the idea or the concept behind it. And how does it work? So the concept here is that you can use AI or ML to help you understand the factors that drive a metric by analyzing your data and ranking the factors that matter and displaying them as a key influencer. So think of a simple example. Let's say you want to predict a variable, you want to predict the amount of sales, for example, for next year, and then you're going to train a supervised machine learning model in order to come up with that prediction. Then this machine learning model will also allow you to get more insights about what were the driving factors, the most important features of that model. And this is essentially what's happening here. So when you select a certain target variable and select a criteria that you're interested in, a high value or a low value for that variable, then this tool will essentially give you an overview of what the most important variables are that are driving this feature. And this is, if you use that in practice, it really feels cool and sometimes a bit magical. But in the end, really, it's no magic at all. In the end, it's just like relying on a lot of frequency counts and a lot of distributions, but being able to analyze so much data at such a short fraction of time, that is what makes the whole user experience really cool. And as you can see here, there are lots of features involved. For example, you can you will directly see for example, a restatement mentioned here under point 3, where you say when target variable goes up, then these when these variables here are increasing or decreasing, then the target variable will go up and down, for example, by and then they give the percentage here of that. So feel free to check that out, for example, in Power BI or any other BI tool you like. It's really cool to see that in action, and also this helps business users to get to insights faster. And as I said, this is not really, giving you the final answer to your problem, and saying, hey, you have to look out for that. But it's more or less like giving you suggestions of areas to look at. So of all the 100 variables that you have in your data set, it will probably highlight the 10 most important ones that you should look at, and that you should look at in what kind of, context they relate to each other, and if it makes sense what this data is trying to tell you. So this is really a cool tool to, speed up your whole data analysis workflow. And again, how is AI at work here? I explained it before. So the basic idea is that you have one output variable, one metric, which is explained by different input variables, similar as we know it from a supervised machine learning scenario. And this is essentially the technique that is powering these kinds of tools. And you can also use that, for example, if you are using an AutoML platform where you say you have a certain data set and you have a certain output that you want to predict, then you can use an AutoML platform, or you can build the model by yourself and do some feature importance analysis and see what are the features that are actually driving the result. And now just imagine that as an interactive application where you can really quickly, change the target feature that you want to analyze. And there you go, and you have a key influencer tool. So this is more or less the basic idea behind that. And so feel free to check out this, these resources here if you want to learn more about that. And I want to spend the last 10 minutes of this talk to really go through a use case with you of how you can turn unstructured data into structured data and into structured tables. And for that reason, I'm going to show you a Jupyter notebook. I'm not going to run it. I'm just going through it, but I want to share it with you. So there's a link here in this presentation. It's called tiny.cc/PDF -computer -vision. Feel free to open the link. It will bring you to the Google Colab notebook, which you can just copy and then run by yourself with any AI service that you would like in this case. And I'm stopping my screen sharing here right now and switching over to the notebook file so we can go quickly through that notebook and see how it works. So this is the notebook. So when you visit that link from the presentation, again, I'm going to share it also after that session. This is what you will see. And this is also an example, which you will find in my book, AI-Powered Business Intelligence. So if you want to get the long version of what I'm telling you now in text form, please refer to, I think it's chapter 7 or so in my book, where this is explained in very much detail. So what's the idea here? And this is, that's my goal for today, to just tell you what would the workflow look like? What's the input, what's the output, and what's the overall setup of that use case? So let's say we are looking at a problem statement. For example, in this case, let's say we're a consulting company in Germany, and we have, salespeople traveling around the country by train. And there's one train operator. In our case, in Germany, it would be Deutsche Bahn. And every train ride they do is just charged on a company credit card. And it's actually a very common business problem here, because when this business is charged by the end of the month, you either have just a bulk a bulk amount on your credit card, or you have every individual transaction, but you don't have any real information of what happened there. So it's just the amount that gets deducted from your credit card, and then you can relate that manually back to the booking. But if you want to have insights, for example, about the trips, including the most popular cities or the costs that were incurred, or the days when people are traveling, it's very hard to get that because there's really no data for that. The only thing which you have is, for example, an online receipt for your e-tickets. Let's say for every train ride that you book at Deutsche Bahn, you will get an online ticket which looks like this here. This is an original ticket. It comes in PDF form. It always looks the same. It looks really complex, but the good thing is it's complex, but it always looks the same. And you can use that now in order to apply a computer vision service in order to extract information from that that you want. And some of you might say, hey, this is just like OCR, and we have done that for years. And I'm saying, yes, OCR is essentially powering that. But if we go through that example, you will probably see how AI is bringing that to a whole new level. So that's our problem statement. So let's say we want to analyze the travel days. We want to analyze the fees that people are incurring, and we want to analyze the main stops and main destinations of to know where people are actually traveling to in our company. So what's the solution overview? I always like to start with a graphic. In this case, I call it a use case architecture in order to really figure out what we want to achieve and what we want to do here. And the way I read this is essentially to start in the user layer. And by looking at the user layer, you can see that in the end, our ultimate goal is that we want to create a report in Power BI which shows us the cost breakdown over time, the total cost per trip, and the top destinations of our salespeople of the consulting company that we have. And the way we do that is that we have some data modeling going on here in Power Query, but this data model is essentially comes from a file source, which in this case is a CSV export, hosted on Azure Blob Storage. And this is where we can jump into the data layer and see how can we actually get to that CSV file that is imported into Power BI. And again, it could also be stored in a database, right? For the sake of this demo here, it's a CSV stored on Azure Blob Storage. So if we go to the bottom left of that use case diagram here, we can see that the starting point, our input, is essentially a list of PDF documents, which we upload in this case to Azure Blob Storage. And then we'll have a Azure Notebook, which is a Python script which loads the files, which calls an AI service for each file. In this case, we are calling Azure Cognitive Services Computer Vision. So we're not training a model by ourselves. We're just using a off-the-shelf model, which analyzes the PDF and gives us, what it sees there. Then we transform the AI results and store that into the CSV file, and this will, then be fed into the BI system. So overall, that's the structure of our use case. Pretty straightforward, I guess. And now we can go actually through that notebook, and please feel free to run that by yourself. The only thing you would need is to create if you want to really follow along with the same example here, you would need an Azure Cognitive Service, or you would need an Azure account, and then set up an Azure Cognitive Service for Computer Vision, which is free of charge. You can use that. They have a free tier. Just Google for that and sign it up. It's just a few clicks. Essentially, you don't have to train a model. You just have to enable that service. And then in the end, you will get an API key and a unique endpoint for you. And then you can go ahead. So I'm importing some packages here. I've also provided the data set here as a sample data, so you can just download the PDFs in order to analyze them. And once you unzip them, you will see a bunch of those PDF tickets, and then we can go ahead and write our function for calling the AI service. So first of all, we're authenticating against the client, and then we have a function that is doing the document analysis, and all it takes is the file path to the PDF file, and then also the connection to the computer vision client. And what happens is then, that it takes the PDF file, sends it to the AI service, fetches the result, and then that's it. No pre-processing. It's just sending the PDF to the API, getting the result, and then storing the result, which is a JSON object, so we can actually pre-process that data later on. Just bear in mind here that I put a sleeper in here because just of the quota limit of the free tier. If you have a production system, you wouldn't need those time sleepers here. That's just for so we don't exceed our quota for the free tier of that AI service. And then, that's the easy part. So that's all it takes to use the AI service. I send the file there, I get a response back. That's it, AI done. And now comes the most complex part. And that's why I want to show you that actually, where the work really is. So if we look at the response, that's how the AI service sees or interprets that document. So all we get back, is a list of, the text or the words it extracted, and then these values over here. I'll come back to them in a bit, what they mean. But this is how the AI service essentially scanned and interpreted our document. So all these things which you can see here. And we can see, there are some values which look like the price, for example, and there are also some values which look like the starting and the end destination. And if we compare that to the actual PDF object, it becomes clear, right, that this is actually just a representation of that, just with in a numerical form, and also with bounding boxes. So how do we get the information that we want? Just to highlight that, these are the information we want to extract. We want to extract the amount, we want to extract the date, and we want to extract the stop stations, the start and the destinations here from that document. So, and all we need to do now is to essentially scrape or go through that AI output and map that with the keywords you want to extract, and also the bounding boxes that this AI service is giving. So the way it works at the AI service, it takes each paragraph or each word and assigns a bounding box, which are essentially coordinates on that PDF document. And now this is how this bounding box looks like. So every word, every paragraph, every sentence, and you're able to look at those different hierarchy levels, have those bounding boxes, and we can extract them from this document. And now we can go ahead and write our functions. For example, the first function could be that we say we want to get text by keyword, which takes the result object from the AI service, a keyword that we define, and as an output, we get the list of elements that just come after the keyword that we are looking for. So, for example, let's say in this case, we are looking for the keyword datum here, which is German for date. We look for that keyword, and then we extract just the character or just the word, not only the character, but the word that is coming after that keyword datum. And then we just need to format that, and there we have, for example, the extracted date from this from this keyword. If we want to extract a table, things get a little bit more complicated because we can, of course, use our keyword approach, for example, to say we want to get text between keywords. We want to have, for example, all text, that goes between Ihre Reiseverbindung and wichtige Nutzungshinweise, because these are always the words that kind of limit the table on that document. Because the position of the table can vary. It can be long, it can be short, but it will always have like this first and this last sentence after that. So we can use the keywords to extract the whole table, and then it will give us, all the information, all the words that were between those keywords. So now only thing we want to know here in this case is, for example, this one here, Leipzig Hauptbahnhof, Leipzig main station, and Hamburg main station, because this was the start and the destination of that travel. So how do we extract that? Well, we use the bounding boxes, because we know that these things are always like located on the left side of that table. So we just filter this result by the result by the keyword search, depending on the position of them on the document, and say we take just everything on the left side. And this is essentially what this code here is doing. So you get the output accordingly, and the only thing you get left from this long list are these two keywords, because these are the only ones that were here on the left side. And then thirdly, we want to extract the price. In this case, it's easy because we can just look for the keyword Betrag, which is just here once in the document, and then we can say we take everything, the next two words or the next two items that come after that. We strip the euro sign here, so we are left with the actual number, and in the end, this is our integer number. So, and if we can do that for one document, we can do that for all documents. And this is essentially how our final data will look like. We get the date, we get the origins, we get the destination, the prices, and the files, and we can now export that as a flat table. And this is how our final table will look like from that single PDF document. And if we now loop over all of the 162 or 1000 PDF documents, all what happens is that each document will become another line here in this table. And this is, everything we need in order to build a nice BI report. For example, in this case, we could say, let me see if I could make this, if I can make this a little bigger here so you can see that maybe a little better. All it takes is, a table like this for all the PDF, documents we have, for all the ticket receipts we have, in order to build a BI dashboard, which, for example, tells us the total costs incurred per year, or the top destinations, or the top total costs per trip, for example, if you combine the destination and the origin train station. And this is really, what happens here in the BI system is really just making beautiful charts and organizing data, but all the heavy lifting is done before. And if we go back to the use case architecture, this is essentially what we just did, right? Everything happened here, underneath the user layer in our data warehouse, in this case, or on our data platform. In this case, we used Azure, but of course we could use also Google Cloud Platform for that. They have AI services which can do that. We can use AWS. They essentially have the AI services, the same AI services that they can use that. So it's basically the same architecture and the same approach here, which means we have everything handled in the backend, and then the BI tool just gets a clean data set. It can visualize, and then the user can interact with that data. For example, using the key influencer tool or the Q&A tool and asking questions like, what were the most popular trips? And then the most popular trips will appear in their BI tool. And that's one example how we can use AI for BI, especially for using unstructured, for making sense of unstructured data and turning unstructured data into structured data. And I hope these examples have shown you that AI can really be used right from the start of making sense of your data when you think about BI, and not only at the end of the BI process, but rather than that, it's an enabler throughout the whole value chain. And with that, I stop sharing my screen. And I really thank you for your attention so far. And I'm really, happy if you have any questions, we can discuss them for now. And otherwise, thanks a lot. Oh, before we go to the question, because I promised you a surprise in the end, and so we don't forget about that one. So let me quickly share my screen once more. And so that's where we left off. So, and here's a quick surprise. So thanks for everyone who stayed, until this presentation until now. I have included a link for you here. It's called tiny.cc/AI for BI/free. And this link will give you 30 days free access to the whole O'Reilly e-learning platform. And on that, you can read my book for free, but you can also read any O'Reilly book you want for the next 30 days free of charge. And you can also attend all the live trainings you can find on the O'Reilly platform free of charge for 30 days. I think it's a great deal, so please feel free to use it. And and with that, thanks a lot for your attention. And also, let's discuss some questions if you have any. So thanks a lot for that.
Amazing. That was a surprise. I didn't expect that myself as well. Thank you so much. So yeah, for now, we don't have any questions in the chat. Thank you so much for the great presentation. Examples were spot on. I really like the example of the PDF and analysis of the tickets. I actually started solving that similar problem long ago. One of the first projects. I obviously didn't succeed with that one, but the example that you showed with these tools that we currently have is much simpler than we could basically, like, maybe 4 years ago or something like that. Even like 2 years ago, it was unprecedented to have those many tools that you can just plug and play and have a full-fledged solution of a PDF and business intelligence on top of the results of OCR, for example. Like, amazing. Thank you for that demo. So guys, how do you like it? Do you have any questions for our friend here? By the way, you got so many thanks because of the surprise.
Thank you very much. Please enjoy.
Yeah. Okay. So at this moment, we don't have any questions. They asked great questions and half of the session. Yeah. So please, like, if you have any questions for Tobias, like, reach to him on LinkedIn. He has a great post that he is posting daily. Or, like, are you posting daily or?
Yeah, sometimes.
Okay. He's posting really often. So
yeah, feel free to reach out, please, to connect. Also, if you have questions after that, feel free to reach out. Feel free to read the book. So really thank you for the opportunity of being here. It was my pleasure. Thanks for asking so many great questions. Really thanks for having me. It was really fun.
Yeah, and we got one question while we were chatting.
Oh yeah, sure.
We got a question about, like, which Power BI platform would you suggest besides Power BI? Like, do you have experience with others or like something like that?
Yeah, I really like Power BI because you have that gets a bit technical here, but there's a thing called Power Query, which is kind of like the data preparation tool inside Power BI. And the good thing is that it's really a good and built-in tool. And if you look at other BI platforms, they started with the whole visualization aspect first, and then kind of acquired other tools or came up with other solutions in order to do the data prep. That's why I like actually Power BI. But honestly, the way I think about it is that I really want to get as much workload done, before actually this data, is being shown to the user. So honestly, I don't really have a preference here. But one thing we have to be aware of, like now with the breakthroughs happening, for example, by ChatGPT or large language models in general, I think we will see so many innovations in those BI platforms, and I think it will be especially, probably more of those younger or smaller BI platforms that will be the first ones to incorporate those techniques, and it will be really exciting to see, how good that will be. So I would really keep an eye on that. Yeah, but otherwise, Power BI is my favorite. Tableau is also nice. Click is also nice. But, yeah,
Nice.
that's how I would see it.
Cool. And like when we are on topic of tools and stuff like that, we got a question. What do you suggest learning for somebody who is actually just starting? Do you suggest like going straight from for like a tool that is a Power BI, or some more fundamental concepts that are transferable to any tool that they can get hands on?
Yeah, I think when it comes to like BI in general, I think it's really good to recap the essentials about data modeling and how data modeling works in the BI's in the BI environment. Things like relational schemas, things like star schemas, things like facts and dimension tables, because this is how typically BI data models are set up. And knowing how to build those cubes or how to build those relationships, I think this can be really helpful also in order to understand how data is modeled once you have the opportunity to work with those BI tools, or B, you are in a position where you need to like deliver data for or predictions for this data which is there. So I think having this understanding is quite good, because once you have that, like essentially all those tools are working more or less the same way. So yeah, that's one thing I suggest. But also, Power BI is free. You can just install it, except for if you have a Mac, then it's not possible. Sorry. So you need a Windows computer for that. But you can also do Tableau or so. But I think, just having something which is kind of a software that also a business user would be using, this always gives you a kind of an advantage, because like what we as a data scientist community always do is like, say, okay, we have our models, we have our frameworks, we just pull up a Streamlit application, or build something in Dash or so users can interact with that. But the truth is, like, people often use the software they have been using forever. So when people are using Tableau in your organization, when people are using Power BI in your organization, I would definitely recommend just looking at those tools and understanding how people are actually interacting with data, because this is the interface that people are using, and they will always use the interface they are most used to. And in many cases, that's not even Power BI or Tableau, but maybe just Excel.
Mm-hmm.
So and I think you would just like think about how people and how consumers are interacting with like your deliverables or with your products. That makes it really gives you a great advantage.
Yeah, that's a great insight. Like I personally love Excel, but yeah.
Yeah.
Great. So to close off the session, we got one more question, which is more on futuristic side of things. How do you see the work of ML practitioners evolve in the next couple of years with all things that are currently happening?
So I think there will be a small core of ML practitioners that is really doing research work, groundwork, probably working for maybe a dozen companies or so who can really build large models and deliver models at a large scale. Maybe more than that, but it's definitely not thousands. But I think so. This will be the ML research side. But the other side will be, taking things which are out there. So this could be a pre-trained model. This could be an ML platform. This could be anything which is there, and trying to put that into production, putting that into a product, and delivering that to a user. So very much like applied focus. I think what we have seen so far of people doing both, like research and application, I think they will kind of like just split up in two groups. There will be people who are very much focused on putting things into production, and then there will be people who are very focused on doing the research and doing the groundwork. Because honestly, for like daily business purposes, there's not much research left. Like, you have XGBoost for tabular problems. You have those large language models for text data. So, what do you want to research? The task is now to put these things to production. But still, like, they are still open and large, large research topics. I don't know, transformers for computer vision maybe. But most companies won't be in a position to really do that research work. That happens at the big players in the market. That's my opinion, how I see it.
Nice. Yeah, similar to my opinion, but yeah, still important to learn fundamentals so you can grasp like the production
Yeah,
side
definitely,
of things. Yeah.
definitely. Yeah, I think just think at some point you need to decide, like, do you want to, like, read papers and do research, or do you want to put things into production? I think it will be very hard to keep both up.
Yeah.
The longer we look into the future, because I think those areas will, like, drift further apart, because every one of those areas will have more specialized and more focused problems. ML ops people having their problems of deploying things and making sure about things like data drift and collecting user feedback and like all these things, and then researchers, like, trying to solve those hard questions. But the fundamentals, like, all of them need that. That's no doubt, 100%.
Yeah, makes total sense. Like in my experience as well, like in the teams that I led, like for example in the photomat, like you had a couple of researchers that purely done research, no knowledge of the code, quality of code, and putting things in production whatsoever, and you need to manage them and actually practitioners who are going to clean those codes and actually put something in production. So it's really specialized in a sense of like what is and in the end-to-end process, but still like you can't work with one or the other. You need both components to be successful in the market. Amazing. Okay, I think that's it. Thank you so much for joining us today. It was an amazing session. I personally learned a lot. I hope for people here as well. So yeah, guys. Thank you again for amazing session and for amazing comments that you delivered to us today. The next session that we are going to have will be this Wednesday, where we are going to jump on the office call, but that's going to be a bit longer, 2 hours, because of the Twitch mishap that happened last week, and we don't have the recording of the last session, so we are going to repeat things from the session before if you have any questions and stuff like that. Because of that, due date for our homework for this week is extended to the next week as well, so you have enough time to revise and repeat everything that we are going to talk about: introduction to machine learning and classification. And this Friday we are going to continue with the normal way, where we are completing with the classification and jumping on regression. So stay tuned for that. The next week we are going to have again the same time, same place session with another speaker. So we are going to talk about that more on Friday. You can always reach me on LinkedIn. You can always reach Tobias on LinkedIn as well, and Discord as always, like whenever you want. Thank you so much for joining us today, and see you soon. Bye.